today we are going to discuss about RT-PCR, which means real-time polymer chain reaction. It is a technique used in a molecular biology for monitoring the amplification of the DNA molecule during the PCR. It is invented by Carey Mullis in 1984 and has an application in many fields like forensic, biotechnology, and diagnosis, etc.
So let's start with reverse transcription. Sometime what we want to find is made of RNA like a virus. A regular PCR only works with DNA, so we need a special first step. Think of RNA as a single standard recipe. Reverse transcription uses an enzyme like a tiny chef to making a matching DNA copy of that recipe. We call this copy cDNA. Now it's time for the PCR. Imagine the PCR reaction as a soup. So we need a few key ingredients, which are primers, DNA polymers, and probes. So what are primers? These are short DNA bits that guide where the copying start. Think of them like bookmarks. And DNA polymerase is a special enzyme. It's a builder that reads the DNA recipe and adds the right building block. Probes. These are like flashlights that stick to our target DNA. As more copies are made, the flashlights shine brighter. All these ingredients, along with our cDNA, go into a tiny tube. That tube gets loaded into the real time PCR machine and ready to start copying.
DNA amplification. DNA amplification is occur towards the three steps: denaturation, annealing, and extension. The denaturation is occur between to 95 to 96 degrees centigrade. Here, the breaking down of double-stranded DNA is formed into a single-stranded DNA by breaking down of the hydrogen bonds. In the annealing, the temperature is lowered towards to 50 degree to 65 degrees centigrade. Here, the primers are bind towards the specific end of the single-stranded DNA. The third step is known as the extension, which is known as 75 to 80 degrees centigrade. We use the enzyme which is known as the Taq polymerase enzyme is used to the DNA polymerase synthesize a new DNA strand which is complementary to the DNA template strand by adding free DNTPs from the reaction mixture that is complementary to template strand. So this is the time required which is used to amplify the DNA at the further steps.
I'm going to tell you about data analysis and application plot. So imagine a graph showing a particular brightness at spatial dye using in PCR. At first it is flat, not much glown, but then the line explodes upwards. This means our targeted DNA is being copied over and over, making the dye brighter. The faster it will happen, the main targeted DNA we started with. Think of the PCR machine as having stopwatch. It records the exact cycle where the glow gets super bright. Scientists call this value as a CT value. An early CT value is like a faster number finishing a race. It means a lot of the starting DNA. Scientists have a chase sheet. To figure out the exact amount, they compare the CT value of our unknown sample to sample with known amount of the DNA. This way, they can pinpoint the exact amount of the targeted DNA we started with.
Yeah. Real-time PCR is a technique. It is used for quantifications of nucleic acid present in the sample using or either fluorescence dye or probe-based technique. Real-time PCR, it is also called qPCR. It is quantitative PCR, qPCR, polymerase chain reactions in which amplification and simultaneously quantifications of a target DNA in the same PCR machine. Real-time PCR of calculation of the starting template concentrations and in the frequency used and analytical and evaluating DNA copy number, viral load SNP detections or allelic discriminations.
Real-time PCR is a powerful tool. It's way more sensitive than older ways of finding DNA and RNA. Doctors and scientists use it every day to help us understand our bodies, fight diseases, and even keep our world safe. And who knows, maybe someday one of us will discover an even better way to look at the tiny building blocks of life.